Now we're going to start actually developing the simulation. So I'm going to create a dot network. I'm going to wire the geometry to the first and the constraint to the second and call this tree RBD sim. Then I'll dive inside. First thing we're going to do is we're going to create a multi-solver, followed by a rigid body solver, a stop solver, and a pop speed limiter, a pop drag spin, and a pop drag. And we're going to start just by going from left to right. So first I'll just wire all these together, plug them in, like so. On our rigid body solver, I'm going to check a set to bullet. I'm going to change the sleeping time to a very high number. And I'm going to change this from graph coloring to islands. And I'll leave the rest at default for the time being. Now, on the stop solver, I'm going to dive inside. And I'm going to create an output node. Wire this up. And I'm going to create an attribute wrangle. And I'm going to call this collision ignore PW for point wrangle. So what we're going to do here is we're going to tell it that if the bullet is asleep, we don't want any collisions of itself to be taking place. If we go back up to our SOP level, we can see here under the inactivity, we've given it the collision group of just self. So when I dive inside here, I'm just going to write a little bit of X. I'm going to write if bracket at bullet underscore sleeping equals 1, close bracket. Create 2 more, tab, S for string, at collision ignore equals self. So now when the bullet is sleeping, not sleep. Just gonna check I wrote that all correctly. Yep. So now while the simulation is asleep, no self collisions will be happening, therefore nothing can turn itself on by mistake. Great. Next, on the pop drag, we're going to set the air resistance to 0.1. Then on the pop spin, we're going to leave it all the defaults. And on the pop speed limiter, we're going to set a maximum spin to 10 and our maximum speed to 10 as well. Next, I'm going to create a merge node. Plug that into the objects to be processed. I'm going to create a RBD packed object. I'm going to set to first context geometry. I'm going to call this tree. I'm going to call the object tree packed RBD. I'm going to wire that in. Now I'm just going to create a normal RBD object. I'm going to call this collision RBD and wire that in as well. And this one doesn't have that same option, so I'm going to quickly jump out a level, and I want to grab our rock, which we want to fling through our tree. So I'm going to grab that null, go into here, and paste it into the stop path. Now in the initial state, I'm going to set the initial velocity just to 30. I want to raise it up a little bit, set it to 2 and -1. The rest of it, I'm just going to leave at default for the time being. On the tree RBD packed primitive, we're going to go to the bullet data, and we're going to turn off shrink collision geometry. Doing this yourself, you probably want to play with this. Defaults are usually pretty good. I noticed a little bit of jumping around when I had this set to the defaults, but often the times the defaults can actually be more stable. Another thing too is I'm going to increase the angular threshold just to 100. Next, I'm going to create the constraint network. So first off, I'm going to create a constraint network. Oh, it's all capitals. Constraint. No, thank you. Constraint network. I'm going to plug that in to there. I'm going to create a bullet soft constraint relationship. I'm going to plug that into the constraints to create. I'm going to set my stiffness to 50. I'm going to turn on the override angular stiffness and dampening ratio. I'm going to set that to a value of 15 and the following to a value of 4. Down here on the data name, we need to get whatever we have called our constraint name here. So our one was soft bullet. So I'm going to copy that and just paste it here. On my constraint network, we need to tell it where to get it. So that's our second geometry, our second context geometry. And we're going to turn on use object transform. I'm going to turn off show guide geometry as well. I'll leave it on for now. We might turn it on and off in a second though. Next, I'm going to create another SOP solver. I'm going to plug that in to my constraint solvers just there. I'm going to dive inside. I'm going to create another output node. I'm going to wire this up to the relationship geometry this time. I'm going to create an attribute wrangle. Now here, this is what's going to break our constraints when the right correct forces are applied. And we look at this out constraints here. And if I change this strength ramp, and I lift this up, you'll see that the tops now, the strength has decreased as the color has gone down. So basically we need to tell the bullet solver that if the thresholds go above if the impact thresholds go above our strength thresholds, the constraint should break and not bend. So back in our RBD sim, I'm going to go back to the SOP solver, and I'm going to write another little bit of X. So I'm going to write if bracket at force is greater than F at strength, then I'm going to write remove prim 0, at prim num, 1 close bracket, and finish it off. Really important, I missed this the first time recording this. Make sure you set your attribute wrangle inside the SOP solver connected to your constraint network to a primitive just there. So when you make it, it'll be points. It's very important you set that to primitives. Going to go back up a level. I'm going to now create a merge node. Wire it in all together. I'm going to create a ground plane. Connect that. And I'm going to switch this to mutual. And for my own sanity, I'm just going to put the ground to be the first input. Now we can see that we have generated our constraints. As we can see next to our geometry, we have our rock. For sanity's sake, I'm just going to turn off the preview of our constraints for now. Right, and the last thing we're going to do now is going to create a gravity force, and we're going to plug that in to the last step just there. Now we'll hit play. And just like that, we can see it's actually all working. Yep, just like that, we can see it's working. Our rock collides with our tree. There's a little bit of a bend, and then when the force is too much, it breaks off. And you'll notice that all these twigs and stuff stay connected because the force hasn't quite reached there yet, and just the real brute impact on our fractured area and the large constraints just now. So next step is I'm just going to speed up the next part of the video. I'm going to do a quick file cache and just cache out. It's going to cache out the tree. So to do that, I'm going to go up a level, create 2 DOP imports. I'll call this tree DOP imp, and one for the rock DOP imp. I'm just going to set this to fetch geometry from DOP and fetch geometry from DOP. I'm going to copy the DOP itself, paste it into the top, just there. Dive inside, grab the name, paste it there, and grab the name of my rock as well, and paste it in my mask. Now when I flag it, oh, see, I've got the GUI error again. If I jump between the two, it fixes it. Let's go back to the rock. Great. So a little file cache. I'm going to speed this part up. Alright, and the simulation is done. That took about 6 minutes to do the proper sim, another 2 minutes to save the rock once it had finished. So I'm just going to quickly check it out. Oh. I didn't set this to load from disk. There we go. Yep, great. The rock hits the tree, breaks the constraints, and destroys the tree.